Okay, now next thing we want to talk about will be reliability and validity. So let me get into that. And they are important. Any instruments, any measures, we need to make sure they are reliable and valid. Okay. So first, reliability. What is that? The key is consistent. Okay. Each time the result of the measure is consistent. So for example, a reliable weight scale. You buy a weight scale in Walmart and you step on it 5 times, and every time it give you 120, 120, 120, 120, right? That's reliable. So a good operational definition or measure should be reliable. Now, there are different types of reliability in research. Uh, First, inter-rater reliability. That means different observers measure the same responses then compare. And usually used in the qualitative content, but not necessarily. Okay. So, for example, you observe children. We did this previously, right? So we observe 2 kids, their aggression level, and we have like 3 people to independently rate their aggression, right? And we have this clear criteria, and they rate it independently, and then they compare, and their rating should be similar. That is inter-rater reliability. Okay, in children's study, you study children. Usually, will ask children's parent, teacher, and the peers, and they three will the result of these three will compare. That's the inter-rater reliability. We have also test retest reliability. It's easy to understand, right? So we see if an instrument, for example, personality test, is reliable by testing people twice and then compare the 2 scores. Interval maybe 2 months. They enough time for them to forget about the original questions. Um, does every instrument need a stable test retest reliability? Not necessarily. It depends on what do you measure, right? If you measure the current mood, then you don't need a test retest reliability, right? Because people's emotions kind of like change all the time. Okay, inter-item reliability. There are 2 major approaches, and they all measure internal consistency. One is a split half. So we randomly split a test into 2 halves, and then I have people to do the first time, do the second half, and then we compare. And then the second one is pretty popular, used really often. Crumpets alpha. It's the correlation of each item with every other item. Okay, and the alpha has to be about point at least like 7 or 8 in order to be like reliable. Okay. Now this is the example test retest, and you can see the correlation is quite close. Yeah, quite related. Just 2 times a week apart. Anyway, and this is split half. All right, and this is a self-esteem scale. Just so you know. Now validity. Validity is measuring what you're supposed to measure. Measure. So only being reliable is not enough. A reliable weight scale always give the wrong answer, right? That is not valid. So for example, I step on the weight scale 5 times, and every time it come up 120. Yeah, this is the example we just get, right? Well, but actually my weight is like 130. Then that scale is reliable, but it's not valid. Okay. So for validity, it's much trickier. Okay, it's not as easily measured as reliability. Um, Usually, for an experiment, to establish the validity, we use a manipulation check to see if our manipulation is really successful. So, for example, we create this high anxiety versus low anxiety condition. Later, we need to ask the participants how much they are stressed, right? How much they feel the anxiety. in order to and then compare to see if our manipulation is really successful. That's why remember this, manipulation check is always at the end of the study, at the end of the experiment. Okay, so now there are different types of validity. Face validity actually is quite not useful. It's just a self, it looks like it's valid, okay, but unless you test it, you don't know. Content validity. Does the content of a measure reflect the content of the quality? For example, a measure in depression. Um, and the questions are not related to depression, then it's a low content validity. Now, in the exam, if I teach experimental side, but the exam tests a physiological side, then this is a very low content validity, right? So if the question do not reflect what is taught, then this exam has a low content validity. Okay. Predictive validity. Can the procedural test help us to predict future behavioral performance? A perfect example is SAT, ACT, or GRE. GRE is if you want to go to graduate school, usually graduate programs will require you to take this standardized test. The idea is this. This test will predict your performance in the graduate school. SAT is the same, predict your success in undergraduate school. Now, are they really valid in the predicting the performance? Well, we don't really know. But I heard a case. Harvard University used to accept some students. They send out these admission letters. Later, to find out, they made a mistake. Those people who got admissions actually are people who are unselected. They are not. They didn't get into Harvard. But now they mistakenly invite him to Harvard, and they cannot, you know, um, they cannot say, "Well, actually, we're joking." So they just admit those students, and it turned out they performed fine. They all graduated, or most of them. That's what I heard. Yeah. So it's hard to say. Now, criterion validity. Okay, extent to which scores on a measure correlated with other variables and construct the expected to be correlated with. Let me give you an example. So suppose we develop an instrument to measure anxiety, right? To see if it's valid, we give participants this instrument and another instrument that's known to be valid. And then we compare the score. And hopefully it's highly related. Of course, we don't want it to be perfectly related. Why is that? Because if it's perfectly related, then literally this new one is the same with the old one. Then why create a new one? Right? So they should be highly correlated, but not exactly. Now, discriminant validity is the same idea. It's just kind of like the opposite. Now, to which the scores on a measure are not correlated. And now, be careful, not correlated. Okay, it's the correlation should be close to zero, or low correlation, but not negative. Negative means related. Okay. So, okay, sorry, I probably need to give you some example. So, suppose anxiety and depression. I don't think they are exactly the same thing. So, if you are creating a measure that measure anxiety, then you give people anxiety. This is a new skill, and also depression instrument, and they should be low correlation, right? Because they should be different. That's a discriminant validity. All right, so that's reliability and validity. Now there are some terms, please just remember, but they are very straightforward. So I just posted for you to learn, just so you know. I don't think this is too difficult to understand. But if you have any questions, just email me. Finally, if in the study you have a study in that you need to use instrument, how do you use that? Do you need permission? For example, my main research is about sexism, and in 1996, this researchers they created this instrument called the ambivalent sexism inventory. So I want to use this skill. How do I use that? Do I need to get their permission? Do I need to email or call them? Actually, we don't. Okay, that would be too much trouble. Either for both for me and for the authors. Okay, just make sure we cite the study. Okay. Now, where do we find this instrument? Usually, you just find the original article, and they will post the instrument on the study. Sometimes they don't. Then you probably now you need to email them and ask for the. Now, if they patent it, they use that to make money. Now you need to get their permission. Okay, but most of the studies it's just that they just published and as a public knowledge, so you don't need their permission. Okay, so the idea is usually is to publish the paper to find the inventory.